Okay, so let me pull up a kind of a blank screen here too. So the first three things, just to remind you, come on. First thing I said was basically be able to tell me the molar mass of anything. If I give you a useful periodic table, so you have to be able to go to the periodic table and figure out what the molar mass of any atom is, any molecule is, and you know how to do that. And so I would give you 1 mole of something, and you would have to tell me what the molar mass of that was. Okay, and then we said, if I give you a number of grams of a substance, you can calculate the number of moles. And what I've said that I'll do is that I'll give you this formula as far as molar mass and grams and mole. What's the relationship between the molar mass and the grams and the moles? But you'll have to be the one to be able to rearrange this to make it so that you can calculate for other things. So if I'm asking for grams or if I'm asking for moles, you have to be the one that's going to be able to rearrange this formula. But I'll give you this formula, and on the study guide I'll remind you that in order to be able to get to moles, so remember molar mass is grams per mole, right? And there's no reason you can't remember this, right? Because molar mass means this, mass per mole, grams per mole. But if I need, but I'll still give it to you, but if you need to be able to find moles, the way that you're going to isolate moles is that there's 2 ways that you're going to be able to do that, right? You could multiply both sides by moles, and moles cancels out there, and that leaves you with grams equals moles times molar mass. And then you can divide by molar mass, and that cancels out there, and that leaves you with moles equals grams divided by molar mass. Okay, that's one way that you can get there. Or the other way, which is a lot easier, is just simply to remember that if you have something that's in a denominator that you want to get by itself, you want to isolate that by itself, all you do is switch the denominator with what's on the other side, right? And that would leave you with moles equals grams divided by molar mass. Okay, so very easy to get from molar mass to moles. And so in the second type of thing that I'm going to ask you to do, if I gave you 317 grams of this, you'd have to tell me how many moles that was. Okay? And you could also, if you wanted to, instead of calculating the molar mass separately, which you would have to do in some way, is that you could actually just calculate the molar mass in the denominator like that if you wanted to. Either way would be acceptable. And then we said, if I give you a number of moles, if I give you a number of moles, you calculate the number of grams. And once again, you would have to know how to get from molar mass equals grams per mole. And this time, this is a lot easier. All you have to do is just multiply both sides of the equation by moles, and that gives you grams equals moles times molar mass. Okay? So, any questions about basic use of the molar mass formula? If I give you a number of moles, so for example, 3.96 moles of glucose, you would have to figure out what the molar mass was, but you would multiply moles times that molar mass, and that would give you the number of grams. Any questions about how I get from the molar mass formula to these other two formulas? No? We're all comfortable with that. Oh, by the way, honor students, you'll have to know these formulas. Okay, so you'll have to know. And so in this study guide, what I've done is I've put a box around the formulas that I'll give you on the test. But honor students, you'll have to know these formulas. You won't get these formulas. But they're not really that difficult, right? You're honor students. Or if you want a chance for some extra credit, if you're not an honor student, I could not give you those as well, and you could get some extra credit for that. And honor students, yes, there will be an opportunity for you to get extra credit too. It's not just you get to do the harder work, okay? So, next thing, particles. If I give you a number of moles, you tell me how many particles. If I give you a number of moles, you tell me how many particles. And even though I've written this out, let's walk through this. This math sucks. When we talk about a number of particles, we use big N as the number of particles, okay? There's not really a unit for that, it's just N. Big N means number of particles. And specifically, in A stands for Avogadro, and this is Avogadro's number of particles, 6.022 times 10 to the 23rd particles, okay? And in particular, it's the number of particles per mole, okay? Number of particles per mole of substance, okay? And what I need you to be able to do is, if I give you a certain number of moles, you tell me the number of particles. So if I gave you 0.59 moles of water, and again, this is written out for you, so you don't really need to write it out again, but you can take notes. Would tell me, because I need you to show me a formula, the formula that you're going to need to show me is the number of particles equals Avogadro's number times the number of moles, right? And I've shown that to you on the... And it doesn't matter which way you put it. You could put moles times Avogadro's number times moles. You can see I'm not very consistent with that either. But that would be the formula that you need to use. And I'll give you that formula on the test. And you would just simply write, and let's put this the other way, since that's what's on the study guide. So number of particles equals moles times Avogadro's number equals 0.59 moles times 6.022 times 10 to the 23rd particles. And in this case, it would be not particles, but molecules. Okay, so molecules . per mole. And I always want you to be in a position where you can see how your units are going to cancel out. Okay? And that's going to leave me with molecules as my unit, which is what we want. And I don't think we went ahead and calculated that. You could do that on your own. But that's going to give you a certain number. Okay? So however many particles that is, I want you to be able to calculate a number of particles for me. Okay? Now, we don't use this very often, okay, because we don't really have a use for the number of particles other than as a concept, but I do need to make sure that you understand how to make this calculation. So I'll only give you one of these as a problem, but I do need to make sure you know how to do this. And then on the other hand, if I give you a number of particles, you can tell me a number of moles. And let's see, what did I say? Oops. 4.96 times 10 to the 19th. Okay. So if I give you a number of particles, you'll have to be able to rearrange this formula, N equals moles times Na, so that you isolate moles, right? And all you would need to do is divide both sides of the equation by Na. Okay? And I don't need you to show me the isolation. You don't have to do that. Okay? If you can do that in your head, that'd be great. But then you get moles equals the number of particles divided by Avogadro's number. And the reason that I recommend that you do this is because it's exceedingly difficult to remember these formulas. Even after decades of doing this, I still, in order to make sure I've got it right, have to write out the main formula and then derive the other formula, because I'm never sure in my mind whether the moles is Na over N or N over Na. Okay? It's something that still hasn't become intuitive to me, just so I can just write it down. I have to actually figure it out from the main formula, because I forget, because I don't use it often enough to remind myself. So it's just easier for you to do it from scratch, and you don't make any mistakes that way, right? If you start with the actual formula, you don't make any mistakes when you isolate the other thing. So in this case, we said we have 4.96. So I would give you 4.96 particle, or times 10 to the 19th. And what did I say? Actually, does someone have one of those? Where are the extras?
In here.
Give me the extras. I'm sorry, you okay? Okay, so I said 4.96 times 10 to the 19th chlorine ions. Okay, so that's how I would give this to you. And then you would say moles equals N over Na equals 4.96 times 10 to the 19th ions over 6.022 times 10 to the 23rd ions per mole. And again, it's so important. You probably don't think that, and it looks like actually in the notes to the study guide, they didn't ask you to do that. But I do want you to put the units here that you're talking about, because that way you can see how they cancel out, and that leaves you with the number of things that you want. And again, the reason that I suggest that you do that is because it will keep you from making mistakes. If you put the units in the wrong places, you'll get final units that don't make any sense, and that will tell you that you've made a mistake. Okay? The other thing that I would encourage you, you have an opportunity here when you're doing these kinds of problems with these large exponents to practice how to predict what your answer is going to be, right? By the time that you do this, you should know that when we divide exponents, we subtract the divisor from the dividend, and we say 19 minus 23, and you would expect then that you're going to end up with somewhere in the range of 10 to the negative fourth as an answer. And if you ended up with 10 to the 42nd as an answer, you know that you did something wrong on your calculator, right? And so just trying to give you some additional, information about how you can make your calculations more successful. And we didn't calculate what that ended up being, so I'm just going to put some dots there. But it would be in the range of 10 to the negative fourth, as you can predict that, and use that as a opportunity to gain some skill in that. Okay. Any questions about 4 and 5? These are skills with particles that I need you to have. Okay. Okay, so skills with particles. Then comes the molarity skills. Okay. If I give you a number of moles and a volume, you tell me the molarity. Okay. This is the very basicest, or the most basic of the molarity formulas. It's just molarity equals moles per liter. And so if you're not an honor student, I'll give you this formula. If you're an honor student, I won't give you this formula. You'll have to know it. But that's only 3 formulas that you have to know as an honor student that you don't have to know as a non-honor student. And the quantity here again tells you what the formula is. Just like molar mass, mass per mole, tells you what the formula actually is. Molarity also tells you what the formula is. Moles per liter. Molarity, the larity begins with L, and that reminds me that it's moles per liter. Okay, so molarity, moles per liter. And in this most basic of the skills, if I give you a number of moles and a volume, you tell me the molarity. So if I give you 2.17 moles of magnesium oxide and 6.2 liters of a solution, you're going to write down moles per liter equals 2.17 divided by 6.2, and that would give you the molarity. And again, I didn't want to take up the time to calculate that out. You can do that if you want. But are there any questions about that basic skill, molarity? Okay. Okay, so molarity skills. If I give you molarity and a volume, you tell me the number of moles. Okay, how many moles did I use? Okay, you need to be able to, because I won't give you this, you need to be able to figure out the number of moles from the molarity formula. Molarity equals moles per liter, okay? And it's just a simple matter of getting moles by itself. And I'm just going to multiply both sides of the equation by liters, and that will give me moles equals molarity times liters. Okay? And then I just use that formula to solve my problem. Okay, so if I give you molarity and volume, then you tell me the number of moles. Now, recognize that there is a danger of confusing that mole formula with moles equals grams divided by molar mass, right? Okay, so don't confuse those two formulas. You've got two formulas that you can use to find moles. If you are using this formula, this won't work here because I haven't given you a number of grams. You can certainly figure out the molar mass if you wanted to. But anyway, very basic. Now, also remember that you'll have to know how to convert milliliters to liters. And the way that you'll do that is that you recognize that if I say 360 milliliters, that's the same thing as saying 360 thousandths of a liter, right? That's the same thing as saying 360 thousandths of a liter. So you would just move the decimal place over 3 spots. So if I said 25 milliliters, you would say that's the same thing as 25 thousandths or 0.025 liters. Or if I said 6 milliliters, that's the same thing as 6 thousandths, 0.006 liters. Okay? So anytime I give you milliliters, your first thought should be, I need to change that to liters. And you just move the decimal place over 3 points. Because milli means thousandths, right? Okay. Come on. Okay, so in this case, you would just multiply. If I gave you 360 milliliters of a 0.45 molar solution of sodium nitrate, then you would say moles equals, well, I forgot to write out the formula. You would say moles equals molarity times liters. And then you would say that equals 0.360 times 0.45. Again, remember, you always need to write out the formula. Formula, substitution into the formula, and then the calculation. Okay. Any questions about how to find the number of moles if I give you molarity and the volume? Now we switch it up again. If I give you moles and molarity, tell me how many liters or what volume. Same circumstance here. I have to be able to change my molarity formula. Molarity equals moles per liters. I have to be able to change this formula into one that isolates for liters. And again, remember my trick. All I have to do is just switch those, and I get liters equals moles divided by molarity. Okay? And I'll need you to be able to do that. Okay. So if I say you have 32.5 moles of potassium hydroxide, and it's a 0.006 molar solution, how many liters is it? Liters equals moles per molarity equals 32.5 divided by 0.006. And again, notice how the units cancel out. Moles cancels out, and that leaves me with liters. Okay? Always be in a situation where your work can tell you if you screwed up. Okay? If your units do not work out to the correct thing that you're expecting, then you've made a mistake, and you need to go back and fix it. It's not just because I'm a control freak that I'm asking you to do that, although I am a control freak. Okay? Now, all of these previous 8 skills here are the basic skills, and the goal of knowing all of those basic skills is so that you can do more complex things. Okay? All of these 8 skills are skills that are embedded in more complex problems in the laboratory. And you have to be able to show me that you know these skills, and that's the basic thing. But then you also have to be able to show me that you can use these basic skills when they're embedded in other types of problems. Okay? And the first type of thing that we need to be able to do is bring grams into the mix here for molarity. Because I'm never going to tell you, go into the laboratory and measure out 9 moles of something, right? We can't do that. I'm going to tell you to go into the laboratory and measure out a certain number of grams. Okay? So we need to be able to bring grams into the molarity situation. So if I give you a number of grams of substance and volume, you tell me what the molarity is. Okay? And the way that you start these more complicated problems is still the same way that you start any other problem. You write out a formula that gives you the answer. Okay? You write out a formula that gives you the answer. Except in this case, the formula that gives you the answer does not have all the information. You have to go back and figure out some additional information. So if I ask you to tell me what the molarity is, the way that you start that problem, no matter whether it's just a basic problem or a more complex problem, is you write down the formula that gives you molarity. Molarity equals moles per liter. And again, this is the one that I will give you on the test. But then the others you're going to have to work out on your own. So you're going to have to say moles equals moles per liter. Oh, wait a minute, I don't have moles. I'm going to have to go figure out what moles is. And, oh, by the way, I know another formula that's not this formula that will tell me that. Okay, so this is where using that second formula for moles comes in. Okay, remember moles equals
liter or moles per liter?
Huh?
Is it moles times liter or moles per liter? Actually, never.
For molarity?
Never mind.
Moles is moles times liters, right? Or molarity times liters, right? Okay? If you always use the big M for molarity and the word mole for moles, you'll keep that straight. Okay? So, yeah, absolutely. Make sure that you know that moles or molarity means moles per liter. Okay? And then you go and find moles this way. Grams. I've given you grams, right? If I give you 12.5 grams of sodium hydroxide and a volume of 3.5 liters, I've given you grams so that you can figure this out. Oh, by the way, you also need to figure out what the molar mass is. I don't have the molar mass, so I need to go figure out the molar mass. Okay? And if you build this strategy into your brain, you'll never, ever, ever not be able to do a problem. Okay? You know how to write down molarity equals moles per liter. And then you know how to say, oh, wait, I don't have moles. And then you know how to write down, oh, wait, moles equals grams divided by molar mass. I've got grams. Oh, wait, I don't have molar mass. So you go figure out molar mass. There's nothing here that you really have to think about. You just follow the logic of the formulas. Write down the formula, inspect the formula. If you need more information, write down another formula, and then inspect that. You may develop a situation where you have a chain of 4 or 5 iterations of this. Oh, I don't have this piece of information. I need to write down another formula. Oh, I don't have that piece of information. And that strategy will carry you a long ways if you do that. But anyway, let's figure out the number of moles. Moles equals 12.5 grams. And, oh, there's the molar mass divided by 40. That equals 0.31 moles. And then I go back and plug in that 0.31 moles. And, oh, I've been given the liters, so I can figure that out. 0.31 divided by 3.5. And I didn't bother to calculate that. Any questions about this? This strategy is so important for you to develop. It's a backwards way of doing things. Very few people can actually look at a problem like this and intuitively go, oh, I need to find the number of moles, then I can find my molarity. Okay? It's not really something that people, unless they practice and practice and practice for a long time, develop. And this is always still the way that I solve problems. Any questions about if I give you grams in a volume? Okay, if I give you molarity in volume, be able to tell me the number of grams. And this is the one that's really important in the lab, right? Because this is the one where I'm going to have to go and figure out how many grams to use when I'm making a solution. Okay, and we make a lot of solutions in the laboratory, so this is really important. And this is the one where we actually created a procedure in our procedure for that last lab to do this, okay? This is important enough that we created a procedure for it. So if I give you molarity and volume, be able to tell me the number of grams you need for that. And as with any problem, the first thing you do is that you're going to write out the formula that gives you the answer. Grams equals moles times molar mass. Oh, wait, I don't have either of these things. I'm going to have to go figure it out. Moles. I know that the number of moles. Now, in this case, I can use the molarity formula to help me instead of the grams formula. I can't use this formula to find moles for me. I have to use the other one. Moles equals molarity times liters, because that's what I gave you, right? Molarity and liters. And in fact, you should develop a sense about this. If you see that I've given you molarity and liters, you automatically know you're going to have to find the number of moles at some point. So I've given you 2.6 liters of a 1.42 molar solution of rubidium chloride. Okay, of rubidium chloride, and you say, okay, how many grams is that? Oh, grams equals moles times molar mass. I don't know the number of moles. Moles equals molarity times liters, and I go calculate that. It's going to be 1.42 molar times 2.6 liters equals 3.69 moles. Okay, I've got that piece of information now. I've also got to go find the molar mass of rubidium chloride. And that's going to be 85.47 plus 35.45 equals 120.92 grams per mole. Okay, now I can finish that calculation. So grams equals 3.69 moles from there, 120.92 grams per mole from there, and that equals 446 grams. Any questions about that? Okay. Then the granddaddy of all of these problems. Basically, how would I set up the laboratory that we did with another equation, another reaction? Okay? So you need to be able to apply all of this stuff to the laboratory. That's the whole point, right? That's the whole point of chemistry. You need to be able to apply these skills to a laboratory. So this last problem, if I give you a balanced chemical equation and volume and molarity data and grams of a product, you tell me a percent yield. Okay? Now, this problem is going to incorporate every one of those other skills. This is why we do this. This is why we're so intense about all of the other skills. Because you need to be able to put them all together to accomplish something fairly significant. So, the example that I've given you here, so what's the name of this compound? Na2O. Don't make me put questions about naming on the test, too.
Nitrogen oxide?
Huh?
Nitrogen oxide?
Is Na nitrogen?
No, it's
Sodium.
Sodium, okay. So, sodium oxide, exactly. And sodium is a metal and oxygen is a nonmetal, so what kind of a compound is it, ionic or covalent? Ionic, thank you. Metal, nonmetal is ionic, right? And this kind of a reaction, this double replacement that we talked about, and we'll talk about more in the future, involves two ionic compounds. I've got sodium oxide and copper nitride. So Cameron, there's the nitrogen, right? So copper nitride, and I get 3 copper oxide and 2 sodium nitride. And I'm not asking you to know how to balance equations like this. I'm just asking you to use a balanced equation to get information. Okay, so what this is saying is if I have 3 moles of this, it will react with 1 mole of this. Okay, if I have 3 moles of this stuff, or if I have 3 molecules of this stuff, it will react with 1 molecule of this stuff. It's just telling me the ratio of how many of these I need for how many of these. I need 3 molecules of this for 1 molecule of this. I need 3 moles of this for 1 mole of this. And if I do this, I should get 3 moles of this and 2 moles of this. The number of moles of stuff on each side of the equation doesn't have to be the same. I've got 4 moles of things here, right? 3 moles of this and 1 mole of this. That's 4 moles of things. I've got 3 moles of this and 2 moles of this. That's 5 moles of things. It's not the number of moles that needs to be the same on both sides. It's the mass of things that needs to be the same on both sides. That's what it is, the conservation of mass, right? Not the conservation of moles. But anyway, this balanced chemical equation says 3 plus 1 of these things gives me 3 of these plus 2 of these things. Okay? But I don't want to use 3 of those things. I don't want to use 3 of those things and 1 of those things. I want to use a much smaller amount. Okay, I want to use a much smaller amount, and I'm going to tell you how much I want to use by telling you that I'm going to give you a 0.1 liter solution of 0.3 molar sodium oxide. That's what I mean here when I say I'm going to give you volume and molarity data. This is the volume data, right? 0.1 liter. And this is the molarity, right? 0.3 molar. And anytime you see volume and molarity, your brain immediately goes, I need to find a number of moles. Right? When you see volume and molarity, I need to find a number of moles. Okay? But I'm not going to make you figure this out on your own. I'll give you some guidance here. So for part A, I'll say, show me the moles of substances to make each solution. So you're going to make a solution of this, and you're going to make a solution of this. Sodium oxide and copper nitride. You're going to make those two solutions. You're not actually going to make it. We're just pretending. But you're going to tell me how many moles of those substances I need to make. And because you're amazing chemistry students and you've just burned it into your brains that moles equals molarity times liters, for part A, you're going to immediately show me moles equals molarity times liters equals 0.3 moles per liter, right? For that, 0.3 moles per liter times 0.1 liters equals 0.03 moles. And then for the second part of part A, this solution, 0.1 liters of a 0.1 molar solution, the number of moles is 0.01 moles. Okay, now I want you to understand how consistent this is with the balanced chemical equation. I need 3 things of this and 1 thing of this. Well, that's the same thing as having 0.03 moles of this and 0.01 moles of that, right? It's just a ratio, 3 to 1. That's still a 3 to 1 ratio. If I have 0.03 moles of this, I need 0.01 moles of that. Okay? And if I use 0.03 moles of that and 0.01 moles of that, I should get 0.03 moles of this. Right? Because that's what my chemical equation tells me I should get. That's why we write out a balanced chemical equation, so we can predict what we're supposed to get. But it's just a ratio. If I have 0.03 of this and 0.01 of this, I should get 0.03 of that. You don't need to show me that, though. I'm not asking you to show me that. And then, since I need to make these solutions, show me the number of grams of substances to make each solution. And you go, I can do that because I know that grams equals moles times molar mass. I know that grams equals moles times molar mass, and I've figured out the number of moles that I need. But I haven't figured out the molar mass. Oh wait, I have figured out the molar mass. I can figure out the molar mass of sodium oxide there. And that's 2 times 22.99 plus 1 times 16 equals 1 times 69.8. So grams equals 0.03 times this. So I need 18.59 grams to measure out on my scale, right? Okay, molar mass of copper nitride, 3 times 63.54 for copper, 2 times 14.01 for nitrogen, and I get 218.64 grams per mole of that. How many grams of copper nitride do I need? This many grams, 0.01 moles times the molar mass gives me 2.19 grams. Okay, so if you can do this, you can show me how many, you know how to figure out how many grams you need to go into the lab and measure out to make your solutions. Right? Okay, here comes the really hard part of this. Tell me how many grams of copper oxide you expect. Okay? You know if you use 0.03 moles of this and 0.01 moles of this, you should get 0.03 moles of this. Okay? But that's not the number of grams, is it? But it's the number of moles you expect. And so what we did in our lab when we wanted to figure out how many grams we expected, we just added the word expected to our formula, right? Grams of copper oxide equals moles times molar mass. Well, here's the grams of copper oxide expected. It's the number of moles expected times the molar mass. So 0.03 moles, and you have to figure out what the molar mass of that is, 79.54. I expect 2.39 grams of this. Okay, not only do I expect 0.03 moles of this, but I've calculated how many grams that is, and that tells me how many I should shoot for. And then I said, I will also give you a certain number of grams of product. So in step D, I'm going to say, you didn't get 2.39 grams, you got 2.06 grams, so tell me the percent yield. And remember, we said percent yield is the grams obtained divided by the grams expected times 100. So you should be able to tell me all of this. Obviously, these are all examples, and I'm not going to give you the same example for the test. Otherwise, you would just memorize everything that I've put on the study guide, right? But every type of problem will be exactly the same, okay? If you know these skills, and I will tell you, I'm going to put more emphasis on knowing the skills than I am on your being able to use the skills. Those are the easier parts of this, so I'll put more emphasis on the easier parts of this. So if you, after studying this, still end up not being able to show me everything I want you to show, it's not going to be as devastating as it could be. But this is what chemists do, right? And unfortunately, some of this is pretty tedious. I can't help that. But if you want to be investigators or you want to do anything in a chemistry laboratory, these are the kinds of things that you need to know how to do in order to carry out investigations related to reactions. You have to have these basic skills here. And I think this test is a pretty good barometer of what you can do in a laboratory. Any questions about any of this stuff? The way that I would do studying, the way that I would study for this is that I would take each of these skills and try to create your own problems. Okay, so for example, I would find formulas for other compounds and calculate their molar masses. Okay, I would create your own little problems. If I give you a number of grams of not sodium hydroxide, but maybe potassium nitrate, say 509 grams of potassium nitrate. Okay, so that would be the way that I would go about practicing these skills, is to create your own little problems to insert into these skills. And I think if you do that, you'll find that there's really not a lot of difficulty here. But I will also tell you that if you were to ace a test like this, you would do better than 60 or 70% of college freshmen on the same test. Okay? And that's because This is these are concepts that take a lot of practice, and unfortunately, not a lot of high school chemistry students get enough practice on this kind of thing, and they don't really understand how to quite do it the right way. And I'm no better of a teacher than anybody else, but if you practice things this way, you'll do really well. Possible opportunities for extra credit will be naming the compounds that I give you. So there will be a blank on the test for most of the compounds that say for extra credit, tell me the name of this compound. So that would be one opportunity for extra credit. Other opportunities for extra credit for non-honor students, again, take the test without getting these formulas. Any questions? Yeah.
Are we allowed a calculator on?
Oh, of course. And I'll give you a periodic table that you can read. Yeah, of course you can use a calculator. I would ask you probably not to program it for those formulas, but you'll get those formulas anyway. So, there's probably not a whole lot that you can do to program it that would be advantageous anyway. But yeah, of course, and in fact, what I'll say is that you can't use your phones. So you all need to bring a calculator to this test, because I won't allow you to use your phones on this. Okay. Questions? Okay, I feel like you should all do a pretty good job on this. You have a week to study for this, so if you are struggling at all, please come in and we'll sit down and do some additional problems together and hopefully make you comfortable with this. These are things you'll see again and again and again throughout the year, so if you don't get it now, you'll eventually get it. Okay. Questions? No more questions? Okay, so you've got 10 minutes left in class. That's your time.
Wait, I do have a question.
Yeah.
Can we retake it? Like, if we get
Yeah, and that's what I said on, it's cutting it close, but the way that they've been doing when we locked grades this year, you should have plenty of time after you get back from break to retake it. Because there's almost no way that I'll have it graded by the Friday. Okay? And I'll be really honest with you guys. I'm sorry about how long it takes me to get things done. I've got 6 different classes, and I have to do both teaching in class and put these online. And I'm literally spending over 100 hours a week working. And so it's not leaving me much time to keep up on grading and things. So if your parents are anxious about your grades or things like that, they can talk to me and I can explain that to them. But I'm working as hard as I can. And I care about your success. So, but I'm more than willing to sit down with you and do extra work with you if you need it. And my experience has been so far that you're all pretty much A students and you do the work. So you're a really good class.